Hi class, this example is for section 5.4, example 5. Here we go. Alcohol and driving. Blood alcohol concentration is known as BAC, is measure. It's a measure of the amount of alcohol in a person's bloodstream. A BAC of, so BAC, remember, is blood alcohol concentration, okay? So a BAC of 0.04% means that a person has 4 parts alcohol per 10,000 parts blood in the body. Relative risk is defined as the likelihood of one event occurring divided by the likelihood of a second event occurring. For example, if an individual with a BAC of 0.02% is 1.4 times as likely to have a car accident as an individual that has not been drinking, the relative risk of an accident with a BAC of 0.02 is 1.4. So this is after you have found the answer, then this is reading the answer to it. The relative risk of an accident with a BAC of 0.02 is 1.4. Recent medical research suggests that the relative risk, which is R, which is super important, okay, of having an accident while driving a car can be modeled by an equation in the form of R equals e to the power of kx, where x is the percent of the concentration of alcohol in the bloodstream. So that's what x is. It's defined for you. R is already defined. R is this piece right here, okay? R is relative risk. And K is defined more for us. K is a constant. A constant means it's not going to change. Part A. Research indicates that the relative risk of a person having an accident with a BAC of 0.02 is 1.4. Find the constant K. So let's go back to your equation, okay? Remember, R is the relative risk, okay? So R is the relative risk. E, it's E, okay? E, it's about approximately 2.718 ... Okay, you have a calculator, you're going to use that in a little bit. K is constant. Okay, so K, constant. And X is the percent. Okay, percent of alcohol. All right, so part A wants us to find constant. We know what the relative risk is. It's 1.4. We know what the percent is. This is X. We're just going to plug it in. So R is 1.4. So 1.4 equals E, we're looking for K. So K is K times X is 0.02. Okay. Then from here, you're going to have to help me solve this. Solve for K. To solve for K, we need to isolate, obviously, K by itself, okay? So we're going to do the natural log to both sides. So natural log of 1.4. What you're doing to the left, you have to do it to the right. Natural log of E of to the power of K times 0.02%, which is, I'm just going to write it in order, okay? 0.02K. Then ln of 1.4 equals ln of E is always 1, so 0.02K. Divide both sides by 0.02. And then K is about, so let's go to my calculator. We said ln. Ln of what? Let me see, sorry. Ln of 1.4. So I think with this kind of calculator, I'm just gonna hit clear really quick. 1 0.4, and then I'm gonna hit ln, okay? So that gives me a value of, let me make this a little bit bigger. Sorry, give me a second, guys. I'm trying to make this screen a lot bigger so I can show you how to use a calculator. There you go. Oh, I'm having a hard time. Okay, let's do that one more time. So 1.4. Oops, that's 14. Can't do that. Clear. So 1.4. Dude, why can't I do 1.4? Give me a second. There you go. So 1.4 ln. Instead of on your graphing calculator, you would be able to punch in ln of 1.4, but on my silly calculator here, it's not allowing me to do that. Okay, so see how this is saying 1.4 ln of 1.4? That gives me that, okay? So with this, I'm now going to divide that. Let's see what my division was. So take my answer and divide that by 0.02. Okay, so take that. So I'm going to take that divided by 0.02%. Okay, so here's my constant. 16.8236. Let's round it to 4 decimal places, okay? So 16.8236. All right, so K, it's about 6, oops, let me move this down for a second, guys. There you go. All right, so 16 point, what was it again? 16.8336, 8236. 8236. So 8236. And that's what K is. Okay. So currently we have an equation. Let me just fill that in with K involved. So relative risk is R equals E to the power of, we know K now, 16.8236 times X. Okay. All right. Using the value of K, what is the relative risk if the concentration is 0.17%? Okay. Now keep in mind this is a really high percent of BAC. The legal California for ages greater than 21 is 0.08%. Okay, so the 0.17, it's really high. Okay, but let's find what the relative risk is. So relative risk is, according to your formula, it's e to the 16. It says use K from A, so I'm going to write this over. 8236 times X. So we're just going to plug in X. So e to the 16.8236 times X is 0.17. Okay, keep in mind that it does not want you to convert this out in decimals. The X is the percentage, so keep it as percentage. So here I'm gonna try to go back and use my calculator. Let's see how good I am at using my calculator. You ready? Okay, clear this out. I'm gonna find E somewhere. E. Nope, that doesn't work. This is my first time using this, so don't mind me. Let's see. Let's do 16.8236 times 0.17. So, okay, so 16.8236 times, all right, ready? 16.8236 times 0.17, 0.17. Let's see what that answer is. Okay, that's my exponent. Then now I'm going to raise e to that power. So e to that power. Okay, let me move this up so you can see what I'm punching in. Okay, can you see that e is to that power? So now the answer is about 17.46. So 17.46 is my answer. So this is 17.46. So you are 17.46, okay, times more likely to get into an accident. At BAC of 0.17%. So you are 17 times more likely to get into a car accident if you have a BAC level of 17%. Okay? All right, next we're moving on to C. Using the same value for K, what BAC corresponds to a relative risk of 100%? 100% means you are 100%, you are 100 times more likely to get into an accident. So we're going to use the same equation. R equals e to the K, which we already have, 16.8236 times X. So it gave you the relative risk of 100%, so we're going to plug that in. E to the 16.8236x. You have to take the natural log of both sides. So natural log of 100 equals natural log of e to the power 16.8236x. Okay, that goes to 1. So now you have natural log of 100 equals 16.8236x. Divide both sides by 16.8236. Okay, let's see what x is going to come out to be. Let me use my calculator one more time. I'm still learning how to use this, so you are just going to, okay, so I'm going to punch in 100, okay, and I need to take the natural log of that, so that's the natural log of 100, and it wants me to divide by 16.8236 and hit equals. Okay, so you have an alcohol level of 0.27%. So according to my calculator, it says you have an alcohol level of 0.27%. Okay, so we're gonna spell this out. Okay, so you are 100 times more likely to get into an accident if your BAC is at 0.27%. Okay. Honestly, at 0.27% is such a high level of alcohol that you're probably gonna pass out. Okay. If the law asserts that anyone with the relative risk of 5 or more should not have driving privileges, at what concentration of alcohol in the bloodstream should a driver be arrested and charged with DUI, which is driving under the influence? So now it's looking for, you already know the relative risk. You are looking for, it says here, at what concentration of alcohol. So make sure we know what we're looking for. So the relative, let's write the equation again. R equals e to the 16.8236x. They gave you 5 for the relative risk. So 5 equals e to the 16.8236x. I'm going to take the natural log to both sides. Okay. Then from here, we will have ln of 5 equals to 16.8236x. I'm going to divide both sides by 16.8236x. So with the calculator, x is about, so I'm going to punch in ln of 5 first, okay? So let's clear out what I had before. So 5 ln, so that's ln of 5, gave me about 1.609. Then I'll take that and then divide it by my, this is my k value, 16.8236. Hit enter. So about 0.96% is what I'm looking at, okay? So about 0.096%. So let's spell that out. A person should be charged with a DUI, okay, at a BAC of 0.096%. Okay. Keep in mind that in California, the legal limit for 21 and over, it's only 0.8. So if you know, that means the relative risk of 0.08 should be lower, okay? All right, so this is the end of our word problem. I will see you on the next video.